Welcome back everyone to my channel Chemistry Made Simple for NEET. I am Dr. Radha Subramaniam with a PhD in Chemistry. So today we are going to do a quick revision of equilibrium part 3. Already I have uploaded part 1 and part 2 of equilibrium. Those who haven't watched those videos can watch it first and then come back to this. So before I start with today's topic, let me mention about the benefits of self-study. Self-study is rewarding to those who have had an independent mindset since the beginning. Self-study can benefit in many ways, and I'll explain a few things here. Students who are trying to explore more deeply during self-study, it will help learn the concept with more interest. Even if questions are presented in a complex manner, students can answer them well as they will have understood every part of every chapter very well. Self-study can build confidence within students. This kind of confidence is what is required in the medical field. Self-study enables the student to engage on tough topics without any help. They naturally try to solve the question unaided, and since the students are independent, it works in their favor. Using the self-study method, students can prepare for NEET at their own pace. They can study according to their most productive times. This can reduce the exam stress and pressure on students by a great level. So now we will move on to the important concepts of the lesson, equilibrium. So already we have learned covered the important topics from this lesson, and now let us just go through the factors affecting the acid strength. So extent of dissociation of any acid, it will depend on the strength and polarity of the HA bond. So strength of the HA bond decreases as the energy required to break the bond decreases. That is, HA becomes stronger acid. Okay, so as the size of A increases down the group in the periodic table, HA bond strength decreases and so the acid strength increases. Remember that A is for atom and H is hydrogen. So electronegativity of A increases, the strength of the acid also increases. You know, all acids are found with hydrogen atom. See, for instance, HCl contains H, HNO3 also H. So proton is present or hydrogen atom is present in all acids. Now size increases in this order. The acid strength also increases like HF, HCl, HBr, HI. Along this direction, the strength of the acid increases. Then electronegativity of central atom will increase. That is acid strength here in this order. CH4 less than NH3 less than H2O less than HF. So remember that order also. And ionization constant of weak acid. So general formula for dissociation of weak acid, it is given by this formula. Just remember this formula. Ka is called the dissociation constant. Hereafter we will mention dissociation constant, or it is also known as ionization constant. And at a given temperature T, Ka is the measure of strength of an acid Hx, which is larger than Ka. So the strength of the acid will be larger than the value of Ka. The stronger is the acid. So it is a dimensionless quantity. With all species, they have the concentration of 1 m. Okay, now solubility product constant. So solubility product constant we denoted by Ksp. So solid salt has a formula with molar solubility S, that is in equilibrium with its saturated solution. Maybe you can show it by this equation, and you can refer to the textbook also for the equation. So Mx and Xy, and it's a reversible reaction. Xmp and that is aqueous ion plus Yxq. Okay, now next solubility product constant we give it by Ksp is equal to from the previous slide you can see Mp plus raised to x, xq minus raised to y is equal to xs raised to x, ys raised to y, and you can just split the terms and write x raised to x, y raised to y, and s is a common factor, x plus y, law of indices, you know, all of you have learned this in maths. So s raised to x plus y, keeping this term alone here, you bring this these two factors down over here. So Ksp denominator, you will have x raised to x into y raised to y. So you get an equation like this, and the term here Ksp in the equation is given by Qsp when the concentration of one or more species is not the concentration under equilibrium. So then what you get is Ks is equal to Qs, but otherwise it gives the direction of the process of precipitation or dissolution. Now common ion effect in solubility of ionic salts. Suppose if you increase the concentration of any one of the ions, it combines with the ion of its opposite charge and some of the salt is precipitated again. And the contrary, concentration is decreased, more salt will dissolve to increase the concentration, because the system will try to increase the concentration by dissolving more salts of both ions, where it will be again precipitated. And solubility of salts of weak acids like phosphates will increase at lower pH, because at lower pH concentration of anion will decrease because of protonation. That will in turn increase the solubility of the salt. And what is protonation? It is a process of addition of proton to an atom or ion, forming conjugate acid. So, see, when you first read all these concepts, you will be finding it difficult, but keep on repeatedly reading these points, so you will follow it well. It's very simple only. Okay, next, effect of inert gas addition. Suppose if you keep the volume constant and an inert gas such that argon is added, which does not take part in the reaction because it's an inert gas. So, the equilibrium will not be disturbed, because the addition of inert gas at constant volume, it does not change the partial pressure or molar concentration of substance involved in the reaction. The reaction quotient changes only if the added gas is a reactant or product involved in the reaction. Okay, now what is common ion effect? This is very important of solubility of ionic salts. Suppose if any one of the ions concentration is increased, then it should combine with the ion of its opposite charge and some salt will be precipitated. We already saw this once. And concentration is decreased, more salt will dissolve to increase the concentration, and solubility of weak acid phosphates increase, that we saw already. Now, concentration of water is omitted from the denominator, because water is a pure liquid and concentration remains constant. Water is incorporated with an equilibrium constant to give a new constant Kw. We call it ionic product of water, H plus and OH minus. And we can distinguish acid, basic and neutral solutions by the values of H3O plus and OH minus concentrations. For acidic, it is H3O plus is greater than OH minus. If it is basic, it is less than OH minus. Neutral means both will be equal. See, very simple. Next, ionization of acids and bases. Now, always stronger acid will donate a proton to the stronger base. Strong acids dissociate very easily in water, resulting in the formation of a weak base. So, always strong acids have weak conjugate bases. So, remember why strong acid has weak conjugate bases. Examples are perchloric acid, hydroiodic acid, nitric acid and all that. Weak acids have strong conjugate bases because opposite. Examples are hydrofluoric acid, acetic acid and all that. Now, acid base strength. In any acid base reaction, equilibrium will always favor the reaction that moves the proton to the stronger base. See here, HCl plus H2O gives H3O plus Cl minus. So, H2 is stronger base than Cl minus. So, equilibrium lies to the right, far to the right. K is not measured because K is greater than 1. Now, di and polybasic acid and di and polyacidic bases. Many acids like oxalic acid, sulfuric acid, phosphoric acid, they have more than one ionizable proton per molecule of the acid. We call such acids polybasic or polyprotic acid. Whereas dibasic acids are those acids which have more than 2 ionizable protons, and tribasic acid has 3 ionizable protons. So, higher order ionization constant, smaller than the lower ionization constant. So, it is difficult to remove a positively charged proton from a negative ion due to electrostatic forces. Okay, now Arrhenius concepts of acids and bases. So, what Arrhenius theory says that what are acids? These are substances which dissociate in water to give H plus aqueous, and bases substance which produce OH. HX gives H plus and X minus. HX plus H2O gives H3O plus X minus. So, water forms bond with hydrogen ion to form hydronium ion, bipyramidal trigonal shape. Now, we say that the degree of hydrolysis is independent of concentration of the solution. pH of such solution is found out by the pK values. pH of solutions can be greater to 7. So, difference is positive, and it will be less than that chart is given in the textbook. You can see that acidic, then 7, and basic, that slide is given in the textbook. So, you can remember the pH values. 7 is taken as a standard. Now, the equilibrium relation between Ka and Kb, equilibrium constant for a net reaction after adding 2 or more reactants equals to the product of the equilibrium constants for the individual reaction. So, for a conjugate acid base pair, K net is K1x K2. So, Ka x Kb is equal to Kw, and P Ka x pKb will be equal to pKw, which is equal to 14. Remember that relation. And hydrolysis of salts and pH of their solutions. So salts are formed by the reaction between acids and bases in definite proportions, which afterwards undergo ionization in water. Cations and anions formed on ionization of salts either exist as hydrated ions in aqueous solution or interact with water to form corresponding acids or bases. The later process of interaction between water and cations or anions or both of salt is called hydrolysis. Then effect of temperature changes. In general, temperature depends on the delta H for the reaction. So the equilibrium constant for exothermic reaction will decrease when temperature increase. In this case, delta H will be negative. Equilibrium constant for endothermic reaction increases as temperature increases. This is delta H positive case. Then raising the temperature shifts the equilibrium to the left and decreases its concentration. So remember all these points. Effect of catalyst. So catalyst will increase the rate of a chemical reaction by making available a new low energy pathway for conversion of reactants to products. So it increases the rate of forward and reverses reaction that pass through the same transition state, and it does not affect the equilibrium. And what does the catalyst do? They lower the activation energy so that the forward and reverse reaction may exactly be the same. So for both forward and reverse reaction, exactly the same amount the activation energy is lowered by the catalyst. Catalyst does not affect the equilibrium composition of a reaction matter, nor it appears in the balanced equation or in equilibrium constant expression. And if a reaction has exceedingly small k, catalyst would be of little help. Remember this. Then according to Bronsted-Lowry theory, what is acid? It is a substance which is capable of donating a hydrogen ion, and bases are substances capable of accepting hydrogen ion. In short, acids are proton donors and bases are proton acceptors. Remember PD, proton donors, bases, proton acceptors. The conjugate pair, see acid 1, base 2, acid 2, base 1. Remember this. So here this is a conjugate pair, base 2 and acid 2. So here the pH scale of hydrogen ion concentration is extended by another species and quantities. So steps 2, how will you evaluate pH for weak electrolytes? The species present before dissociation is identified as Bronsted-Lowry acid bases. Then balanced equation for possible reactions with the species acting both as acid and base are written. Reaction with higher ionization constant is identified as primary reaction. There is a subsidiary reaction. Enlist tabular form and follow the values of each of the species into the primary reaction. Initial concentration, and change the concentration into equilibrium in terms of its degree of ionization, and then equilibrium concentration. So with that we are coming to the end of this section, and this is I have made the notes very simple for all of you to understand. Just revise them very well and try to remember and retain all the concepts. So with that we are coming to a conclusion of this unit, equilibrium. I hope you all enjoyed learning this as well as I enjoyed in teaching you the concepts of this important lesson. And as always I say, please do share, subscribe and like my channel. Do share it with your friends, and don't forget to press the bell icon so that as soon as I post new videos you will get the notifications immediately. So I will be soon coming with a new video, and with that I am winding up today's session. Happy learning and thanks for watching my video.